Top 25 refinery interview questions and answers. Refineries are the backbone of the petroleum industry, converting crude oil into valuable products like gasoline, diesel, and petrochemicals. Working in a refinery requires technical expertise, safety awareness, and problem-solving skills. Whether you are a chemical engineer, mechanical engineer, operator, or technician, being prepared for interviews can make a huge difference. This guide provides 25 commonly asked refinery interview questions along with detailed answers, helping candidates confidently demonstrate their knowledge of refinery processes, safety standards, equipment operations, and troubleshooting techniques. It's an essential resource to prepare effectively and leave a strong impression. 1. What is a refinery, and what are its main functions? A refinery is an industrial facility that processes crude oil into usable petroleum products such as gasoline, diesel, kerosene, and petrochemicals. Its main functions include separation, conversion, and treatment. Separation involves distilling crude oil into fractions based on boiling points. Conversion processes, such as cracking and reforming, transform heavy fractions into lighter, more valuable products. Treatment ensures product purity and removes impurities like sulfur and metals. Refineries also optimize yield, improve product quality, and comply with environmental standards. Understanding refinery functions is crucial for safety, efficiency, and product quality management in daily operations. 2. Can you explain the process of crude oil distillation? Crude oil distillation, also called atmospheric distillation, is the first step in refining. Crude oil is heated in a furnace and fed into a distillation column. Different hydrocarbons vaporize at distinct boiling points and rise through trays in the column. Light fractions like gasoline and naphtha condense at the top, while heavier fractions like gas oils and residues settle at the bottom. This separation allows further processing in conversion units. Understanding distillation is essential because it affects downstream operations, product quality, and refinery efficiency, making it one of the most critical processes for refinery operators and engineers. 3. What is catalytic cracking, and why is it important? Catalytic cracking is a refining process that breaks down heavy hydrocarbons into lighter, high-value products like gasoline and diesel using a catalyst. This process improves yield and quality by increasing the octane number and producing lighter fractions suitable for fuel blending. Catalytic cracking reduces residue and transforms less valuable heavy oils into marketable products. It is vital for meeting demand for transportation fuels and enhancing refinery profitability. Operators must monitor temperature, catalyst activity, and feed composition to ensure efficiency, safety, and product consistency, making it a key area of knowledge during refinery interviews. 4. Explain the difference between hydrocracking and catalytic cracking. Catalytic cracking uses a catalyst to break large hydrocarbons into smaller molecules, primarily producing gasoline and olefins. Hydrocracking also uses a catalyst, but incorporates hydrogen under high pressure, producing cleaner fuels like diesel and jet fuel while saturating unsaturated hydrocarbons. Hydrocracking improves sulfur and nitrogen removal, yielding high-quality, low-emission products. While catalytic cracking is faster and less expensive, hydrocracking is more versatile and environmentally friendly. Understanding the differences helps operators optimize product selection, process conditions, and refinery economics. Interviewers often ask this to assess knowledge of conversion technologies and product strategies. 5. What are the common safety hazards in a refinery? Refineries present multiple hazards, including fire and explosion risks from flammable hydrocarbons, toxic gas exposure like hydrogen sulfide, chemical burns from acids and caustics, high-pressure equipment hazards, and confined space dangers. Operational hazards may arise from hot surfaces, rotating machinery, and high-temperature processes. Safety measures include proper training, use of PP, regular equipment maintenance, gas monitoring, and emergency response planning. Demonstrating awareness of these hazards in interviews shows readiness for a safety-conscious work environment and understanding of the protocols that prevent accidents and ensure personal and team safety. 6. What is the role of a distillation column in a refinery? A distillation column separates crude oil into different fractions based on boiling points. It consists of trays or packing where vapor rises and liquid descends, allowing separation. Lighter fractions condense at higher points, while heavier ones remain lower. Columns may operate under atmospheric or vacuum pressure to optimize separation. Understanding column operation, including temperature profiles, pressure drop, and reflux ratio, is essential for maximizing product yield and quality. Interviewers often focus on this to assess your grasp of fundamental refinery equipment and your ability to troubleshoot and optimize column performance. 7. What is the importance of hydrogen in refining processes? Hydrogen is essential in hydrocracking, hydrotreating, and reforming processes. It removes sulfur, nitrogen, and other impurities, improving product quality and compliance with environmental standards. Hydrogen saturates unsaturated hydrocarbons, stabilizes products, and enhances octane ratings. It also prevents coke formation, extending catalyst life. Operators must monitor hydrogen flow, pressure, and purity to maintain efficiency and safety. Understanding hydrogen's role demonstrates knowledge of both chemical reactions and operational safety, which is critical in refinery operations and often tested during interviews for technical and engineering roles. 8. How do you prevent corrosion in refinery equipment? Corrosion in refineries can result from acidic compounds, high temperatures, and moisture. Prevention strategies include using corrosion-resistant alloys, applying protective coatings, maintaining optimal pH levels, and employing chemical inhibitors. Regular inspection, monitoring corrosion rates, and timely maintenance reduce equipment failure risk. Operators must also ensure proper drainage and avoid stagnant conditions in pipelines. Understanding corrosion mechanisms and prevention demonstrates awareness of reliability and safety in refinery operations, which is critical for minimizing downtime, extending equipment life, and ensuring safe, continuous processing. 9. What is a refinery flare system? A refinery flare system safely burns excess hydrocarbons during emergencies, startup, shutdown, or overpressure situations. It prevents unplanned releases of flammable gases, reducing fire and explosion risks. Flares consist of a flare stack, knockout drum, and gas recovery lines. Operators must monitor flow rates, flame stability, and gas composition. Understanding flare operation and environmental regulations is essential to manage emissions, ensure safety, and comply with industry standards. Interviewers often ask this to assess knowledge of emergency handling and environmental compliance in refinery operations. 10. Can you explain the purpose of hydrotreating? Hydrotreating removes sulfur, nitrogen, metals, and other impurities from petroleum fractions using hydrogen and a catalyst under high pressure. It produces cleaner fuels, improves stability, and prevents catalyst poisoning in downstream units. Hydrotreating is critical for meeting environmental regulations and maintaining refinery efficiency. Operators monitor temperature, pressure, hydrogen flow, and catalyst activity to optimize the process. Explaining hydrotreating in interviews demonstrates understanding of product quality improvement, environmental compliance, and the integration of refining processes for safer, cleaner fuels. 11. What is the significance of octane number in gasoline? The octane number measures gasoline's resistance to knocking during combustion. High octane prevents engine damage and ensures efficient fuel use. Refineries increase octane through reforming, blending, or adding additives. Understanding octane is essential for operators to optimize product quality, meet standards, and ensure customer satisfaction. Interviewers may assess your grasp of fuel properties and the refining processes that influence them, which reflects your ability to produce market-ready products efficiently. 12. How do refineries manage waste and effluents? Refineries generate wastewater, sludge, and gaseous emissions. Wastewater treatment includes physical, chemical, and biological processes to remove oil, suspended solids, and harmful chemicals. Sludge is treated and disposed of according to environmental guidelines. Gaseous emissions are controlled through flaring, scrubbing, or catalytic converters. Proper monitoring ensures compliance with environmental standards and reduces ecological impact. Discussing waste management in interviews demonstrates awareness of sustainable operations, regulatory compliance, and operational responsibility, which is vital for modern refinery roles. 13. Explain the difference between atmospheric and vacuum distillation. Atmospheric distillation operates at atmospheric pressure, separating crude oil into light and intermediate fractions. Vacuum distillation operates under reduced pressure, lowering boiling points and allowing heavier fractions to be distilled without thermal cracking. Vacuum distillation maximizes high-value product recovery from heavy residues. Operators must monitor temperature, pressure, and flow rates to optimize separation. Understanding both types shows knowledge of refining strategies for maximizing yield and efficiency, which is frequently evaluated during technical interviews for refinery positions. 14. What are the common refinery catalysts used? Common catalysts include zeolites for catalytic cracking, nickel molybdenum and cobalt molybdenum for hydrotreating, and platinum-based catalysts for reforming. Catalysts accelerate chemical reactions, improve yield, and enhance product quality. Proper handling, monitoring activity, and avoiding contamination are essential. Explaining catalyst roles in interviews demonstrates knowledge of chemical processes, operational efficiency, and problem-solving skills in managing refinery reactions. 15. How do you handle a process upset in a refinery? Handling process upsets involves identifying the cause, following standard operating procedures, and stabilizing operations. Operators monitor alarms, adjust flows, temperatures, or pressures, and communicate with the control room. Safety is the priority. Emergency shutdown may be required. Documentation and post-event analysis help prevent recurrence. Demonstrating systematic problem-solving and adherence to safety protocols during interviews highlights readiness to manage real-world operational challenges in a refinery environment. 16. What is the role of a reformer in a refinery? A reformer converts low-octane naphtha into high-octane gasoline components and aromatics using heat, pressure, and catalysts. It enhances fuel quality, increases octane number, and produces hydrogen for other processes. Operators monitor temperature, pressure, and catalyst activity to maintain efficiency. Understanding reforming is critical for optimizing product yield, meeting fuel standards, and ensuring safe operations, which is commonly tested in refinery technical interviews. 17. Explain the term residue upgrading in refineries. Residue upgrading transforms heavy fractions from distillation into lighter, valuable products. Techniques include catalytic cracking, hydrocracking, and coking. This process improves product yield, reduces waste, and increases profitability. Operators control temperature, pressure, and catalyst selection to achieve desired outputs. Explaining residue upgrading demonstrates knowledge of maximizing refinery efficiency, utilizing heavy feedstocks effectively, and enhancing overall product quality. Key skills for technical interviews. 18. What is the purpose of a desulfurization unit? A desulfurization unit removes sulfur compounds from petroleum fractions, producing cleaner fuels and meeting environmental regulations. Methods include hydrodesulfurization using hydrogen and catalysts. Sulfur removal prevents corrosion, reduces emissions, and protects downstream catalysts. Operators monitor temperature, pressure, and hydrogen flow to ensure effective sulfur removal. Knowledge of desulfurization is essential for environmental compliance and product quality, making it a critical interview topic for refinery roles. 19. How do you monitor refinery process efficiency? Process efficiency is monitored using key performance indicators like yield, energy consumption, product quality, and downtime. Operators analyze flow rates, temperatures, pressures, and catalyst activity. Continuous monitoring, process optimization, and regular maintenance improve efficiency. Interviewers ask this to gauge your ability to assess performance, troubleshoot issues, and implement improvements, reflecting your understanding of operational excellence in refineries. 20. Explain the term coker unit in refining. A coker unit converts heavy residual oil into lighter products and petroleum coke. Thermal cracking breaks down large molecules under high heat, producing gas, liquid, and solid coke. Operators monitor furnace temperature, feed rate, and product separation to maintain efficiency. Coking maximizes product recovery from heavy residues and reduces waste. Explaining this unit in interviews shows understanding of residue management, high-temperature operations, and safety considerations in refinery processes. 21. What is the importance of process control in a refinery? Process control ensures safe, efficient, and consistent operations by regulating flow, temperature, pressure, and composition. Advanced control systems prevent deviations, optimize product quality, and reduce energy consumption. Operators must understand instrumentation, control loops, and feedback mechanisms. Interviewers assess knowledge of process control to determine your ability to maintain stability, prevent accidents, and enhance refinery performance through precise operational oversight. 22. How do you handle hazardous chemicals in a refinery? Handling hazardous chemicals requires PPE, proper storage, labeling, and adherence to safety protocols. Operators follow material safety data sheets, MSDS, use spill containment, and ensure ventilation. Training and emergency preparedness are crucial. Discussing chemical handling demonstrates awareness of occupational safety, regulatory compliance, and practical skills in preventing accidents in hazardous refinery environments. 23. What are the key factors affecting refinery product yield? Factors include crude oil quality, temperature, pressure, catalyst activity, residence time, and equipment efficiency. Operational conditions like feed rate and energy input also influence yield. Monitoring and optimizing these factors ensure maximum recovery and product quality. Interviewers often test understanding of yield determinants to evaluate problem-solving and operational optimization skills in refinery roles. 24. Explain the difference between light and heavy hydrocarbons. Light hydrocarbons have low molecular weight, low boiling points, and are gaseous or volatile liquids like propane and naphtha. Heavy hydrocarbons have higher molecular weight, high boiling points, and include gas oils, residues, and asphalt. Processing differs. Light hydrocarbons often go through blending, while heavy ones require cracking or coking. Understanding this distinction is important for operational planning, process selection, and efficiency optimization in refineries. 25. How do refineries ensure environmental compliance? Refineries comply with environmental standards through emission control, wastewater treatment, sulfur removal, and waste management. Continuous monitoring, reporting, and adherence to regulations prevent pollution. Implementing cleaner technologies and process optimization reduces ecological impact. Interviewers assess your knowledge of environmental compliance to ensure you can operate safely, responsibly, and sustainably while maintaining refinery productivity and minimizing regulatory risks. Preparing for a refinery interview requires both technical knowledge and practical awareness of operations, safety, and environmental responsibilities. Understanding processes like distillation, cracking, hydrotreating, and reforming, along with safety protocols and process optimization, is crucial for success. Candidates who can confidently explain equipment function, chemical reactions, and operational troubleshooting demonstrate readiness for real-world refinery challenges. Additionally, knowledge of environmental compliance, waste management, and process efficiency shows a comprehensive grasp of modern refining operations. With consistent preparation using these questions and answers, candidates can approach interviews with confidence and technical competence.